Okay, now I'm starting again with just my blank scene, which is a castle. I do not have a light in the scene at the moment, just kind of a temporary one that was created because the other light was gone. I'm going to go ahead and create a new scene, so File and New, where we have a sunlight that's going to replace our temporary light. Now I do want to maintain my camera, so going over to the camera I had set up, if you want to very easily match this, but still render through the Vue camera so that if you do need to go to the standalone version, everything matches up, we're going to select the main camera, hit M on the keyboard to bring up the motion options. We're going to add a modifier and select the follower. And then we can set it to follow the camera. So the original camera created in LIghtwave, and then the main camera for the Vue scene is now going to follow that. Click Continue. And now, because the aspect ratio and focal settings are slightly different, it's not going to be a complete match at the moment. So we would just need to match up the resolutions to be the same, and also the focal length. I have a 50mm lens on my LIghtwave camera, but my Vue camera is 67, so we'll go ahead and set that to 50. And it does look like maybe it is a different type of camera. Let's go ahead and take a look. And that's because of the way the multiplier is set up. I believe, possibly, could be a unit difference between the two scenes, because I do know that the Vue object, which is the Vue container, which is the Vue scene, which is the parent object to everything within the Vue scene, is slightly off from the actual coordinate system. The position is a little tiny bit off. Not by much, but enough. So it looks like it's because of the frame setting. So go to the camera, and we're going to adjust this. And we're just going to set them both to the 35mm Academy mode. And it still looks like there's that change in the focal, which keeps being off. So we'll reset those both to 50, and now they should be identical. I do need to transfer over some of my other settings. And now we should have a perfect match. So now we could choose to use, and our parent camera is the Vue, or the original LIghtwave camera. So as we modify that and make changes, we can switch over to the main camera for the Vue scene, and it's going to be identical. So that's a pretty nice little setup there. So let's go ahead and make the scene a little more interesting. It doesn't look like the sunlight is set correctly. So we're going to switch over to rotation. And it might just be, it looks like the OpenGL. So I'm going to go over to the atmosphere editor and just check the sun. And we can modify the azimuth and the pitch. And that's going to refresh the scene, and it now looks a lot better. I want to make a few notes about modifying terrains. So we're going to create a procedural terrain. And in the previous section, I was modifying the Y scale and the up and down scale manually. If we go over to Modeler, we can select any of the objects from the scene. So we can see on my scratch disk I've got my procedural terrain. So we can load that in and take a look. and see the real scale. So we'd want to maintain this scale throughout the object in Modeler in case we wanted to use the proxy object to save the terrain as a baked object instead of having to export using it for any dynamics. So if we were to modify the scale in layout, it's not going to update the model correctly. So there's two different ways to modify, or there's two different types of terrains to modify, so we need to modify their scales differently. So I'm going to go ahead and add in another type of terrain. So we're going to create a height field terrain. So we have a standard height field terrain. And the scale of the height field terrain is going to be slightly different, more accurate by default. And that is because the actual output of a procedural terrain is kind of dynamically calculated based on the overall output. Standard terrain has a fixed scale, but they still, it's a good idea to adjust the up and down axis, and so within LIghtwave the y-axis, and you can see the scale, even though the bounding box is not a square, the overall scale is equal when we took a look at the numeric values. Okay, so we're going to start the easiest way to modify the height of a standard terrain. We're going to go to Edit Object, and in the terrain editor, if you have your standard terrain, whether you painted it or generated it with the presets, the easiest way to modify it, if you go up to the top, you can select the Filter Altitudes, and this pulls up the altitude filter. We can right-click on it, edit the filter, and there are 2 points, or at least one point automatically created in the upper right. The other point is the lower range, which can be added in manually. You can double-click to create new key points. We can see a little preview updating with how the new altitude is going to look. We delete the key point. We can show the grid. We can set up snapping. We can also set up curvature. But in this case, we just want a linear decline of the overall height. So what you can do is grab that right point, and the overall output is a value from -1 to +1. So 0 would be the halfway point. So if we wanted to reduce this 50%, we would bring down that point to 0. You can also type in the value manually. Click OK for the filter, and OK to apply the altitude filtering, and that's going to reduce the height of the terrain. So that's the easiest way to reduce the height of a standard terrain, since our scale is locked in the current version, and I am using version 8.4. 8.5 is currently out, but I'm sticking with 8.4 to reach more the current users, because 8.5 just came out. And the new features shouldn't really have too large of an impact on the workflow of the application, just added features to what currently exists. So now we're going to edit the height of the procedural terrain. So what we can do is go in, same thing as before, just selecting to edit the object. And procedural terrains work a little differently. It is controlled by a function. Still, between that altitude amount, or that number value of -1 to +1, being generated by a noise node. So right now we have a simple fractal. Let's go ahead and make it more interesting. We'll make a terrain fractal. I'm going to go ahead and reduce the metascale. And now if you want to preview, you can go up to the top and open up the function output observer. This is going to give you a detailed preview of the terrain, although typically not completely anti-aliased, so some of the details may seem very jagged. But you can make all your modifications to your functions, and it will show up and give you an idea what the terrain is going to look like. Now, because the zero edge mode is turned on, we see a fall off on the terrain around the edges. We'll go ahead and click OK. So if we turn off the zero edge mode, we're going to get an open terrain where the sides are not going to come down and level out. So if you want more of a mountainous look, turn on zero edge mode. So this function, now if we want to see the actual output numerically, we can open up the function node preview, and this gives us a reading on the x, y, and z of the overall data output between values of -1 to 1. If we extend beyond the value of -1 to 1, it somewhat gets clamped, and basically it reduces itself automatically. It's a good idea to stay between -1 and 1. Values that will increase that are multiplying or dividing filters, or increasing the gain amount in most fractals. Increase the gain, now we're up over 5. And our extension, if automatic extension is turned on, will show the amount we are going over. Now, if you have your function designed and you have these very high values, one filter that is really nice to reduce that, so we're going to click on the link between the altitude and the terrain fractal, go over to the left, and click on the little F over here, which is a filter. Or you can right-click, add a filter node, and then select. And what we're going to use is the smooth map. Actually, I think we'll go ahead and just use regular map, because the smooth map is going to cut off the tops. And what we can do is set our range to be defined and adjust the overall output. So I'm going to change the output range to -1 to 1, which is our goal. And what we want to do is adjust the input range to change that extension of the output. So since what's being input into this filter is a range around around 5, our upper value should be 5. And our lower value, we're going to go ahead and try -5. And if it's being clamped a little bit too much, we have a lot, in this case, still above 0, or a very large amount, not really going down to -1. So we could do -4. And our extension is 1.01. A little hard to see, a smaller number. So we're almost there. So what we really need to do is set the upper value to 5.2, and now we're within the -1 to +1 range. So that's a good way to take any existing functions that are going beyond that value and reduce it. Now, there's a filter that is available outside of the function. So after the entire function is generating the terrain, we can then use an additional filter, just like before, to reduce the output of the height. Now, this is can be dynamically changed. So in other words, the modifications we make to this are not permanent. With the standard terrain, as before, that filter, when you apply it, it permanently modifies the terrain. With this, we can just go back and change the filter again. Raise it up higher if we want. Go back, reduce it. And we don't have to worry about losing any of the data, because it's all stored within that procedural and not within the filter. So if you want to flatten it out, that is the easiest way to do it with the locked scale value. So now we can adjust the scene and the terrains around the objects And I'm going to go ahead and delete, or actually take the procedural terrain and adjust its scale to be something much larger. Go ahead and change the grid size so that we can do this much quicker. And change its position. Move the object back. And let's go ahead and type them manually. So this is going to be our more distant type terrain, and I was scaling the grid the wrong way for faster movement. Okay, and then we're going to grab the standard terrain and stick that in front. We could also use procedural terrain for that, an additional procedural terrain, if needed, for the scale or for the overall detail. But for now, I'm going to go ahead and stick with this. So we can have just a smaller terrain that's going to be a little bit easier to modify around the object. And then the procedural terrain, which is going to be something just going to fill in the overall scene. So we're going to reduce, bring back the Z, negative 100. Let's change the X a little. And I might need to reduce the height even further now, so we can edit the object, go into the filter, reduce that further. And now if that is not creating a dramatic enough effect, you can go into where we had that map filter earlier that we added in. And I'll just show you. Edit the function. And instead of setting the upper value to 1, the equivalent of using the filter, let's say we just set that down to negative 0.5, so almost negative 1, you could just set this to negative 0.5, and that would really reduce the output range. So that would be the same as using the filter. So now we can edit the object material. Let's rename it terrain. And the back terrain. Add an ecosystem layer. Rename the top layer. And I'm going to add in a couple of plants. Now, if you're not familiar with the vegetation, basically the first row that we're seeing here of objects are the low-res, more ecosystem-friendly objects, starting with the dead tree, basically going over to the cypress, possibly a little bit further to the white oak. These ones are very low res compared to the rest of the objects. Some of the other objects will climb up to a couple 100,000 polygons. Now, not all of them. There's a few in here that are still lower res. The plum tree winter was added later because these other objects have been around in Vue since the very early versions, and they are completely separated. But some of the newer variations that came out in version 7 are worked into the rest of the list, but they are sorted mostly in that quality order. As you can see, the HD lime tree, it tells us that it's 250,000 to 350,000 polygons per tree. So if we had a forest of these, that would be a lot of polygons to render and take up a lot more memory. So if we're going to have distant vegetation, we don't need to have really high quality trees. They can be some of these lower quality ones. So we're going to load in and start with the plum tree, add another plant, use the maple tree, add another plant. We can go ahead and grab the cherry tree, which I try not to use because the cherry tree does have some issues. Hopefully we don't run into any problems with it. Mostly it's for close-ups that it has UV mapping problems, but sometimes it has a tendency to change the overall colors to black and render all the plants black. So the scale, because the view unit of 1 is equal to 1 meter, is set to 0.1. If the internal unit was 0.1, I'm pretty sure it would set the scale to 1. That's a very recent change to the way that all of the units are working. So I'll go ahead and populate, and we can see that we have 471 plants being created. Now, the plum tree is very small compared to the rest of the objects. So what we can do is take that plum tree and bring the scale up to 0.2. I'm also going to add the large dead tree. And these lower res objects will also load very quickly. I'm also going to add in the plum tree winter. And we can click populate. Now, instead of going through and modifying the scale of everything individually, we can go over to the Scaling and Orientation tab and adjust the overall scaling of the entire ecosystem layer. So it will reduce the scale of everything. I do want to reduce the scale of the large dead tree a little bit smaller, setting that to a value of 0.06. And then the plum tree winter I'm going to set to 0.15. Go to the scaling and adjust the overall scaling to 0.75 and repopulate. So it's a little bit smaller. It filled in pretty well overall. Now, there's a maximum size variation. Right now, we're set to a uniform value, which only gives us the ability to adjust the X. Now, adjusting the X will actually adjust the X, Y, and Z, because it is uniform. So the size variation is set to 1. So it's going to increase the overall size by 1. So if we had 10 meters, it would increase it up to 20 meters. Or scale it down to around 1 meter, typically. Sometimes it's just a change of 1 meter. That's going to largely depend on the species, because some of them are very wide compared to the others, and they're calculated their height a little bit differently. So it's just kind of something. 1 is the default, works pretty well. We can set that up to 2 to see a little more size variation. So we're basically kind of multiplying the size by 2. Go ahead and click OK. And we can see that a little bit better. Now, one of the options that was turned on is decay near foreign objects. In this case, we have an advantage. We have a standard terrain, which is acting as a foreign object, decaying from the castle. Because the integration of the native objects, or the LIghtwave objects, is not worked into that decay amount. So we then have to use Vue objects in order to create the decay. So by having this other terrain underneath the castle, it acts as the foreign object. Unfortunately, the size extends far beyond the castle, so if we wanted this ecosystem to go all the way up to it, we would have to make modifications to that terrain, or just go in, create an object in Vue, just a box that's not going to render, and dissolve it from there. So here's a render of the current scene. Clearly it needs a lot more vegetation, and if you take a look at the difference between the two types of terrains, the standard terrain and the procedural terrain. The procedural terrain, pretty much all of the detail we're seeing is geometry. That detail is not from bump maps. It is actually generated geometry, because these two materials or two objects have the same grass material on them. The scales might be a little bit different, but for the most part, we can really see the amount of detail get created from the procedural. And the standard terrain, it's basically 256 polygons by 256 polygons, and then divided because they are triangles and not quads. So very low res compared to the procedural, which is probably a couple million polygons. Within xStream, there's no readout or ability to view exactly how many polygons are in the scene. That is something that is only shown when you are within the standalone version. So we're going to go into the procedural terrain and edit the object material. Going to the ecosystem layer, we're going to increase the density. And now we can also adjust the decay near foreign object amount, which is located under density, the influence, and then the fall off. So since our standard terrain is considered a foreign object, we are adjusting the influence based on that standard terrain and then the fall off from that. Populate below foreign objects as possible is whenever you have any sort of overhang or any objects where there's a space underneath it, and that way it'll populate underneath overhangs. It doesn't always work because the population is projected downward onto the terrain. So now we're up to 2012 instances. And because I am recording while doing this, I am having a little bit of a lag here. So I'm going to limit the number of displayed instances down to, let's go to 400. And it is asking me to save my scene. At least I don't believe I saved it yet. Now I also want to select the standard terrain, which is just called terrain, doesn't have procedural in front of it. We're going to edit the object, and I'm going to increase the detail. So we can hit the ×2, which is going to give us a much higher res terrain. And you can also go over to the effects tab if you want to create any sort of erosion on. And this evaluation is controlled by the overall pixel size. So if you start with a lower resolution and apply erosion, step it up a little higher, apply erosion, and then continue to do that, you can get a very natural looking erosion and some very cool looking terrains. Also, using the presets on the left will add to the current terrain, and that's within a standard terrain, height field terrain, and not procedural. Procedural, it will change the actual function. So you may want to limit the filter. Oh, and I did invert it by accident. There's the ability to invert, which kind of gives some pretty cool options. You can also add a function on top of the height field terrains as well. So the same way you can create procedural terrain, you can also create a function to apply to the standard terrain that wouldn't be editable after it's applied. So I'm going to go ahead and filter the altitude and just reduce the output a little more. Click OK. OK again to close out the terrain editor. And now we're going to have something a little bit higher res. Another thing I want to mention is if you do want to have, in this case, this object still in the scene where it's at, and you have another object controlling your decay, but you don't want this object influencing the decay of the ecosystem, you can go to select the terrain and go to the xStream menu. And this is the object properties. It's going to be listed under edit or under object. My menus are customized, so you'll have to take a look and see whether it's under edit or object. So object properties, we have a couple of different options. We can hide the object from the render, occlude from the gbuffer, and this is the option we're looking for, which is ignore object when populating the ecosystem. So this will make it null from the decay, and it'll be completely ignored when decaying. So that way you can have other objects in there affecting that. And then you can also ignore indirect lighting on the object. I also want to note if you're having any performance problems, in your video card settings, you can turn off the transparent anti-aliasing, which can improve the overall system response, because these billboards are going to be hogging a lot of resources if it's anti-aliasing through the transparency and the objects themselves. So you can still get good object anti-aliasing, but keep the billboards a little bit different. And that is defined within the video card settings. So depending on the type of video card you have, it's really going to be dependent on that and not the settings within LIGHTwave or xStream. So I'm going to set up, maybe take a look at that standard terrain. And we could just move that down a little further. And I'm going to be able to creep the ecosystem in a little bit more. That'll look a little bit better. So edit the object material, populate. I also want to note that you can turn on the dynamic population in order to calculate and populate the object instances at the time of render. So when you click render with dynamic population on, it will generate those, and we'll take a look at that more in depth a little later. But what I want to take a look at now, or show you next, is basically how the rendering works within xStream and what renders what. Because there are some specifics to xStream separated from the way or what LIGHTwave is rendering.